Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. In this part 6 video on the chapter of rational numbers, I will discuss about the addition and subtraction of rational numbers and their properties, and also will discuss about what is additive inverse and uh, additive identity of rational numbers and what is additive inverse of a rational number. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side where I will which is about the addition and subtraction of rational numbers, their properties, and the additive identity and additive inverse. Okay, so whenever you have to do addition and subtraction of rational numbers, the very first thing you have to do is to convert the rational number so that it has positive denominator. Now, whenever if you have a rational number with the denominator is negative, then you have to make the denominator positive and accordingly adjust the numerator. So let's say, while I am speaking, you can please follow the notes. And on the right hand side, I will discuss whatever is written in the notes with some examples. So let's say you have a rational number 2 by minus 3. So this is not in standard form. The denominator 3 is negative, minus 3 is negative. So for this to convert it in the standard form, you just make the denominator positive and take the negative of the numerator. So this is equal to minus 2 by 3. Now this is in standard form. Now if you have the numerator is also negative, like minus 4 by minus 10, and the denominator is negative, then this is not in standard form. If both the numerator and the denominator is negative, then you can cancel out both the negatives and this will become 4 by 10, which is in standard form. So in the notes you can see P by minus Q is equal to, the standard form of P by minus Q is minus P by Q, and the standard form of minus P by minus Q is P by Q, because the minus of numerator and the denominator anyway cancels out. Okay, now let's discuss addition of rational numbers. Now if the two rational numbers, we are adding, they both have the same denominator, then it is very simple. We just add the result will be the numerator of the result will be the addition of the numerators of the given rational numbers, and the denominator remains the same. So let's say if we have to add 1 by 3 plus, let's say 2 by 3. So we see both the rational numbers we are adding is 1 by 3 and 2 by 3. They both have the same denominator 3. So this will be nothing but the denominator remains the same and we just add up the numerators. This is 1 plus 2. This is 3 by 3. This is 1. Okay, I will take some examples while I am discussing the theory. Okay, let's say, okay, so this was adding to rational numbers which has the same denominator. Another example could be, let's say, minus 8 by minus 11 by 8 plus 5 by 8. So the denominators of both the rational numbers are same, which is 8. So in the result, the denominator remains the same and we just add up the numerators. So this becomes minus 11 plus 5. This is minus 6 by 8. But minus 6 by 8 it's better, or it's always better whenever you do some calculation and the result is a rational number, always try to make the rational number in the standard form. That is, the denominator should be positive and there should be no common divisor between the numerator and the denominator. In this example, minus 6 by 8, this is not in standard form because 6 and 8 has a common divisor of 2. So we need to divide both the numerator and the denominator by the HCF of 6 and 8, which is 2. So this becomes minus 3 by 4. Now this is in standard form. Okay, now so this was adding to rational numbers when they both have the same denominator. And the number 2 in the notes, how do we add to rational numbers when they have different denominators, like P by Q plus R by S, where Q and S are not same, they are different. So we need to first find the LCM of the two denominators, Q and S. Let the LCM be M. If that LCM be M, then we can write, then we have to convert both the given rational numbers P by Q and R by S to their equivalent form, so that both the equivalent rational numbers will have a common denominator of the LCM, which is M. So we have to convert P by Q so that the denominator becomes M. So the formula is P, you have to multiply both the numerator and the denominator with M divided by Q. What is M? M is the LCM of Q and S, and Q and S are the denominators of the given rational numbers. So it becomes P into P multiplied by M divided by Q, and the denominator becomes Q multiplied by M divided by Q, which is essentially M. So when you convert P by Q to its equivalent form, so that the denominator is M, it becomes P multiplied by M divided by Q by M. Similarly, you will convert the rational number R by S to its equivalent form, so that the denominator is M. So you have to multiply both the numerator and the denominator with M divided by S. M divided by S. So it becomes R into M divided by S divided by M. And then when you add P by Q plus R by S, it becomes P multiplied by M divided by Q by M plus R multiplied by M divided by S by M. Now since both have the same denominator M, in the result the denominator remains the same. We just add up the numerators, which are P multiplied by M divided by Q and R multiplied by M divided by S. Now these formulas, it is absolutely not necessary to remember these formulas. I have just written in the result in algebraic form, so that you can relate what you actually do while solving the problems. This is what exactly you do, but of course you need not remember this formula. Okay, so let's try to understand how with some examples how we so this was for let's try to see how do we add two rational numbers when the denominators are different. So let's say I'm taking some examples from the exercise only, exercise 1C, even though I will solve all the problems of exercise 1C in the next two videos. So there will be two-part video for solving the problems of exercise 1C. So let's say if we have to add minus 5 by 16 and we have to add 7 by 24. Clearly we see that both the rational numbers are already in standard form and the denominators are different. So first thing we have to do is find the LCM of 16 and 24. So usually you find the LCM like this. You take the highest common divisor, that is you can take 4 and divide all the two numbers with 4, and then you can take 2 so the LCM becomes LCM of 16 and 24 is 4 into 2 into 2 into 3. This is 48. The LCM is 48. So we see that the LCM is 48. Now, so what you do is, I have to convert while doing the sum. I have to convert both these rational number to their equivalent form, so that the equivalent rational number will have both the equivalent rational number will have the denominator as 48. Now when I am converting minus 5 by 16, so that it has denominator 48, what will I have to do? I have to multiply the denominator 16 with 3. So I will definitely multiply also the numerator with 3. So this becomes 16 into 3 is 48. And when I will convert 7 by 24 to its equivalent form, so that the denominator is 48, I have to multiply both the numerator and the denominator with 2, because 24 multiplied by 2 is 48. So this becomes 7 into 2 by 48. So this, when simplified, becomes minus 15 by 48. So we have to add minus 15 by 48 plus 14 by 48. Now we see that both the rational numbers have same denominator 48. We just add up the numerators. Minus 15 plus 14 divided by 48. This becomes minus 1 by 48. Okay, let's see another example. Let's say we have to add. So this was regarding how to make a rational number in standard form, and this was about adding two rational numbers with the same denominator, and this was about adding two rational numbers with different denominators. So let me just do some marking for better readability. So this was first example. Let's see another example. Let's say we want to add 1 by minus 12 plus 2 by minus 15. Now we see that both the rational numbers are not in standard form. Both the denominators are negative. Minus 12 is negative, minus 15 is negative. First we have to convert them to the standard form, not standard form actually. We have to make the denominator positive. So 1 by minus 12 will become minus 1 by 12, and 2 by minus 15 will become minus 2 by 15. This is minus 1 by 12. Now we have to add these two rational numbers, and we see the denominators are different, 12 and 15. So we have to find the LCM of 12 and 15. So let's find the LCM of 12 and 15 by the usual method. We see that it divides by 3, so 3, 4, 5, and that is it. So the LCM will be 3 into 4 into 5, which is 60. Which is 60. Okay. So now we have to convert these two rational numbers to their equivalent form, so that both the equivalent form has the denominator 60. 60 is the LCM of 12 and 15. Now to convert minus 1 by 12 to have the denominator 60, we have to multiply both the numerator and the denominator with 5, because 12 into 5 is 60. So this becomes minus 5, minus 1 into 5 divided by 12 into 5 is 60, and to convert minus 2 by 15, so that to its equivalent rational form, so that the denominator is 60, we have to multiply both the numerator and the denominator with 4, because 15 into 4 is 60. So this becomes minus 2 into 4 divided by 60. So now we have to add minus 5 by 60 plus minus 8 by 60. Now we have the same denominator. We will just add up the numerators, and the denominator remains the same. This is minus 5 minus 8 by 60. This is minus 13 by 60. Okay. So I think these examples are sufficient to illustrate the concept of adding two rational numbers where the denominators are different. Okay, what is next? Now regarding addition of rational numbers, we have two important concepts which are additive identity and additive inverse. Now 0 is the additive identity of rational numbers. Why? Because if you add 0 with any rational number, the result is that rational number itself. So if you take any rational number 2 by 3, if you add just 0 to it, the result is the rational number itself. So any rational number you take, minus 1 by 9 plus 0, it is equal to 0 plus minus 1 by 9, this is equal to minus 1 by 9. So this is there is nothing this is a very simple complex concept, and I don't think I need to explain it further. So 0 is the additive identity, is known as additive identity in rational numbers, because if you add 0 to any rational number, the result is that rational number only. Okay, that was additive identity. Now let's now what is additive inverse? What is additive inverse? Now every rational number has an additive inverse. Now what is that additive inverse? So in the notes it says that R by S, the rational number R by S is the additive inverse of P by Q if P by Q plus R by S equals to 0. That is, if you add a rational number and its additive inverse, the result is 0. The result is 0. So let's say P, I have a rational number P by Q, and so if it is the case that we are having the addition of two rational numbers equals to 0, let's say P by Q plus R by S equals to 0, this will imply that R by S is the, short writing additive inverse as AI. Now do not misunderstand AI with artificial intelligence. It is additive inverse. One second, let me write it like this. Let this be additive inverse. Okay. This implies R by S is the additive inverse of P by Q, and P by Q is the additive inverse of R by S. They are additive inverse to each other. So if the addition of two rational numbers is equal to 0, that means that the two rational numbers are additive inverse of each other. Now the question is, how do we find the additive inverse of a number? So let's say if P by Q is a given rational number, its additive inverse will be, you simply negate, additive inverse of P by Q is equal to, you simply negate, that is, take the negative of the numerator. Now whatever the numerator is, the numerator could be positive or negative, whatever it is, you just take negative of it, and if the numerator is already negative, then with negative of a negative numerator will become positive. So you have to just take the negative of the numerator. So then minus P by Q is the additive inverse of P by Q. Let's say, so what is the additive inverse? What is the additive inverse of 2 by, let's take some example that will be better. Let's say, what is the additive inverse of, let's say, minus 17 by 8. This is equal to, you just take the negative of the numerator. The numerator is already negative. So I will negative of the numerator by 8. Now minus of minus 17 is 17 by 8. So this is the 17 by 8 is the additive inverse of minus 17 by 8. And also you can say minus 17 by 8 is the additive inverse of 17 by 8. So this is very important. This is an important concept, that if the addition of two rational numbers is equal to 0, you can say that the two rational numbers are additive inverse of each other. Let's take another example. Let's say, what is the additive inverse of 19 by minus 6? Now always remember, whenever you are doing some operations on rational numbers, always try to make each rational numbers in the standard form, or at least make the denominator positive. So in this case, we are trying to find the additive inverse of 19 by minus 6, which is not in standard form. So we have to first make the denominator positive. So this is equal to, let's first make the rational number having denominator positive. So this is equal to additive inverse of, how do we convert 19 by minus 6 so that it has positive denominator? We just take the negative of the numerator. So this is minus 19 by 6. Now additive inverse of minus 19 by 6 is nothing but you take the negative of the numerator. This is equal to 19 by 6. So 19 by 6 is the additive inverse of 19 by minus 6. Okay, so this was one example, this was another example. Okay, let's take a final another example. Okay, one more thing, important thing is that, please note that the only number which is equal to its additive inverse is 0, because 0 is equal to 0 by 1, and additive inverse, as I have explained, additive inverse of any rational number 0 by 1, 0 is equal to 0 by 1, the additive inverse of 0 by 1 will be equal to, you just take the negative of the numerator, that is minus 0 by 1. This is equal to, there is nothing called minus 0 or plus 0, 0 is 0. So this is equal to 0 by 1 is equal to 0. So 0 is the only number which is equal to its additive inverse. Okay, let's take another example. Let's take okay, let's take minus 16 additive inverse of minus 16 by minus 5 will be equal to, first we have to make the rational number whose additive inverse we are trying to find, make the rational number to have positive denominator. So the denominator is minus 5, so we will just take the negative of the numerator. So this will be equal to additive inverse of, we are converting the rational number minus 16 by minus 5 so that it has positive denominator. So this becomes 16 by 5. Now what is the additive inverse of 16 by 5? You just take the negative of the numerator, minus 16 by 5. So minus 16 by 5 is the additive inverse of minus 16 by minus 5, which is essentially equal to 16 by 5. Okay, I hope the additive concept of additive inverse is clear, and the important thing is that to note, keep in mind, is that the only number which is equal to its additive inverse is 0. There is no other number which is equal to its additive inverse, and that if the addition of two rational numbers is equal to 0, then the two rational numbers are additive inverse to each other. Okay, so that was additive identity and additive inverse. Now let's discuss about the subtraction of rational numbers. Now we subtract, we use the concept of addition only while doing subtraction of rational numbers. So when we subtract a rational number, let's say we have to subtract the rational number r by s from the rational number p by q. So we do like this, we are subtracting the rational number r by s from P by Q. This is nothing but we add the additive inverse of the rational number that we are subtracting, that is additive inverse of R by S. So this is the main concept. We are subtracting the rational number R by S from the rational number P by Q. So it is P by Q minus R by S. This will be equal to, we will just need to add the additive inverse of R by S with P by Q. Now, so this becomes P by Q plus, what is additive inverse of R by S? That is minus R. You take the negative of the numerator of the rational number R by S. So minus R by S is the additive inverse of R by S. So this is the main formula. This is the main concept. So we use the concept of additive inverse and addition of rational numbers to process or compute subtraction of two rational numbers. Okay. Now let's see some examples of doing subtraction of rational numbers. Let's say we have to subtract, example 1, let's say we have to subtract minus 7 from minus 4 by 7. We have to subtract minus 7 from minus 4 by 7. So what is the what is happening here? This is equal to, so we are subtracting the rational number minus 7. Now minus 7, you can always think it as minus 7 by 1. So this is actually equal to minus 4 by 7 minus 7 by 1. We are doing this. So we know that P by Q minus R by S is equal to P by Q plus additive inverse of R by S. So this will be equal to minus 4 by 7 plus the additive inverse of minus 7 by 1. This is equal to minus 4 by 7, and the additive inverse of minus 7 by 1 is, you take the negative of the numerator is minus 7 and negative of minus 7 is 7. So this is 7 by 1. Now this will be, if you do this, the denominators are different, you have to take the LCM. So we see that clearly we have to take the LCM of 7 and 1, which is equal to 7, and so we have to convert both these rational numbers to the equivalent rational number so that the denominator is 7. So minus 4 by 7 remains same, minus 4 by 7, and plus we have to convert the rational number 7 by 1 so that the denominator becomes 7. So this will become 49 by 7. So now this is equal to minus 4 plus 49 divided by 7. This is equal to 49 minus 4, 45 by 7. Okay. Now let's see another example. We have to subtract. We have to find 1 by 3 minus 3 by 4. We are subtracting the rational number 3 by 4 from 1 by 3. So this is equal to 1 by 3 plus the additive inverse of 3 by 4. This is equal to 1 by 3, and the additive inverse of 3 by 4 is minus 3 by 4. So now we have to do this. Now I will skip some steps because I have already explained the concepts in detail so far. So when we how do we find 1 by 3 plus minus 3 by 4? The denominators are different. So we have to take the LCM. The LCM of 3 and 4 is 12. So when we convert 1 by 3 so that it has denominator 12, it will become 4 by 12. And when we convert the rational number minus 3 by 4 so that to its equivalent form, so that the denominator becomes 12, it will be minus 9 by 12, because we have to multiply both the numerator and the denominator with 3. So now this becomes 4 plus minus 9 divided by 12. This is equal to minus 5 by 12. I hope it's clear how we have to do subtraction of two rational numbers. One more example. Let's say one more example. One more example can be, let's say, okay, we have to subtract from minus 6 by 5, we have to subtract minus 32 by 13. We are subtracting minus 32 by 13 from minus 6 by 5. Okay, so this is equal to minus 6 by 5 plus the additive inverse of minus 32 by 13. So this becomes minus 6 by 5, and the additive inverse of minus 32 by 13 is that you just take the negative of the numerator. Negative of minus 32 is 32. Now we have to add minus 6 by 5 plus 32 by 13, and we know that the LCM of 13 and 5 is 65. So this will be, we have to convert minus 6 by 5 to its equivalent rational form, so that the denominator is 65. So we have to multiply both the numerator and the denominator with 13. So this becomes minus 6 into 13, and 5 into 13 is 65. To convert 32 by 13, we have to multiply both the numerator and the denominator with 5, because the denominator has 13. 13 into 5 is 65. So 32 into 5 divided by 65. So this becomes 13 into minus 6 is minus 78 by 65, and 32 into 5 is 160 divided by 65. So now we have the same denominator, we just add up the numerators and the denominators remains the same. So this becomes minus 78 plus 160 divided by 65. This is how much? Minus 20. This is 82 by 65. This is 82 by 65, and I don't know whether you can convert it to this is in standard form or not. I don't think so. I think this is already in standard form. Yes, I think it's already in standard form. So whenever you do some additions or subtractions and the result is not in standard form, it is better that you always convert the result of the rational number with standard form. That is, the denominator should be positive and there should be no common divisor between the numerator and the denominator. So I think the subtraction of two rational numbers is clear. Now let's discuss the properties of addition and subtraction of rational numbers. The properties of addition and subtraction operations on rational numbers. So first is closure property. What does closure property say? If the closure property says, for the operation of addition, if we add two rational numbers, the result is also an rational number. So in the notes you can see both the addition and subtraction are tick mark, meaning that they both satisfy the closure property. That is, if you add two rational numbers p by q and r by s, their sum, that is p by q plus r by s, is also a rational number, and their difference, that is subtraction, p by q minus r by s, is also a rational number. This is a pretty simple concept, and need not explain it with any examples, because you can clearly understand if you take any two rational numbers, their sum or difference will always be another rational number. So the addition and subtraction, they are both closed. the operations of addition and subtraction on rational numbers are closed. So this is about the closure property of addition and subtraction. Now commutative law. Commutative law says basically the concept is that let's say any operation. Now so far you know the operation of multiplication, division, subtraction and addition, but there are many other arithmetic operators which does a different kind of processing or computation on two numbers. Let's say just think that this is some kind of operator. Now this operator operates on two rational numbers. Now we say that this operator is commutative only when we operate this operator on two rational numbers, let's say p by q, and this operator, whatever this operator means, r by s is equal to r by s and this operator p by q. So if you change the order, of the two rational numbers across the operator and the value remains the same, then only we say that this operator is commutative. So addition for rational numbers is commutative, but subtraction is not commutative, meaning you can clearly check that 2 by 3 plus 1 by 3 is equal to 3 by 3 which is equal to 1. Now if you change the order of the rational numbers, 1 by 3 plus 2 by 3 will also be 3 by 3 equals to 1. So you see that 2 by 3 plus 1 by 3 and 1 by 3 plus 2 by 3 is the same. They are having the same value of 1. But if you do consider the subtraction, 2 by 3 minus 1 by 3, this is 2 minus 1 by 3, this is equal to 1 by 3. Whereas 1 by 3 minus 2 by 3 is equal to 1 minus 2 by 3, this is equal to minus 1 by 3. So minus 1 by 3 is definitely not equal to 1 by 3. So we can clearly see that the subtraction operation is not commutative, whereas the addition operation is commutative with respect to rational numbers. That is, for any two rational numbers, p by q and r by s, p by q plus r by s is equal to r by s plus p by q, but p by q minus r by s is not equal to r by s minus p by q. So subtraction is not commutative, whereas addition is commutative with respect to rational numbers. So this was commutative law. The next is associative law. Now associative law says that similarly, if let's say if this is an operator, this one, whatever this operator does, let's say this operator does something on two rational numbers, we say that if p by q, this operator r by s, and this operator t by u, the associative law says that you can for any operator, if you operate if you use the operator on three rational numbers, then the ordering of the rational numbers does not matter. It remains the same. That is, if you consider if you are computing this expression, one p by q and r by s, t by u are three rational numbers, and if you have to operate apply this operator on all these three rational numbers, you can do it in any order, which means that this will be equal to, you first apply the operator on the first two rational number, that is r by s, and then with this result you apply the operator on the third rational number, that is t by u. This will also be equal to if you first apply the operator on the second and third rational numbers, and you apply the operator, the result of applying the operator R by S, applying the operator on R by S and T by U, the result, if you with this result, if you apply the operator with P by Q, this will be same. Now for addition, which this essentially means is that, let's say we have, for example, let's take some examples. 4 by 5 plus 1 by 5. I am taking simple examples with same denominator so that it will be easy for computation. So 2 by 5. This, if we have to find this, then we can use the associative law and do some grouping of the rational numbers and apply the addition like this. We can first apply do the addition of 1 by 5 and 2 by 5, and then with the result of this we add with 4 by 5. So this is basically it means by association. This is also equal to, if we first add the rational numbers 4 by 5 and 1 by 5, and with the result we add the rational number, third rational number, that is 2 by 5. This is what it says about that addition is follows the associative law. But subtraction does not follow the associative law, meaning if you take the same example, now this you can clearly see will be 4 plus 1 plus 2 by 5. This is equal to 7 by 5. This, in this case also, it will be 4 plus 1 plus 2 by 5, which is equal to 7 by 5. Let's see if subtraction follows the associative law or obeys the associative law on rational numbers. So let's see if we want to do, let's take the same examples. Let's say we have to find, we are trying to evaluate, let's say 4 by 5 minus 1 by 5 minus 2 by 5. We are trying to evaluate this. Now let's see if we can use the associative law of subtraction, whether it works or not. Let's say if we first let's first do the subtraction of 1 by 5 and 2 by 5. So we first subtract using the associative law. We first do the subtraction of 1 by 5 and 2 by 5, that is 1 by 5 minus 2 by 5, and this result we will subtract from 4 by 5. If indeed subtraction obeys the associative law, this should be equal. The left hand side should be equal to the right hand side. Now this is equal to 4 by 5 minus, if we do the subtraction of 1 by 5 minus 2 by 5, this is minus 1 by 5. So now this is, we know that, so this is now 4 by 5 minus this is subtraction of minus 1 by 5 from 4 by 5, and we have seen how do we subtract two rational numbers. When we subtract a rational number from another rational number, we just add the additive inverse of the rational number to be subtracted to the other rational number. So this will be 4 by 5 plus the additive inverse of minus 1 by 5. This is equal to 4 by 5 plus additive inverse of minus 1 by 5 is 1 by 5. So this is 1 by 5. This is 5 by 5. This is equal to 1. So the value becomes 1 if we do this association. That is, we first subtract the second and third rational numbers, and then from the result we subtract from the first rational number. Now if we change the ordering, let's see what is if we subtract the first two rational numbers first, that is, we subtract 1 by 5 from 4 by 5, and from this result we subtract 2 by 5. Let's see what is this result. If this result also comes to be equal to 1, then it will prove that subtraction obeys the associative law. But we know that subtraction does not obey associative law, which we will clearly see. Now what is 4 by 5 minus 1 by 5? This is 3 by 5. Minus we have 2 by 5. Now this is equal to we know that using the concept of subtraction of the rational numbers, using additive inverse and addition of rational numbers, this will be plus minus 2 by 5. So this is equal to 3 minus 2 by 5. This is equal to 1 by 5. So 1 by 5 is definitely not equals to 1, and hence we see this implies that 4 by 5 minus 1 by 5 minus 2 by 5 is not equal to 4 by 5 minus 1 by 5 minus 2 by 5. So this proves that subtraction does not obey the associative law on rational numbers. Okay, so that was all regarding the concepts that I want to discuss in this video, that is addition and subtraction of rational numbers, their properties, and the two concepts related to addition of rational numbers, that is additive inverse and additive identity. So I hope the examples I cited is good enough for you to understand the concepts of adding and subtracting to rational numbers, and and understanding the properties of addition and subtraction, that is closure property, commutative law, associative law, and that concept of additive identity, which is 0, and additive inverse, that is two rational numbers are additive inverse to each other if their sum is 0, and also that the only number which is equal to its additive inverse is 0. In the next two videos, I will solve all the problems of exercise 1C, which are based on the addition and subtraction of rational numbers and additive inverse and additive identity, and it will also have some word problems. So word problems is a very common type of problem on the number systems, that is rational numbers, or you have already done word problems in your previous classes on decimals, fractions, integers, whole numbers, natural numbers. We will solve those kind of problems from exercise 1C in the next two videos. So I hope this video was beneficial to you. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Stay tuned for the next two videos where I will solve the problems of exercise 1C, and once all the problems of exercise 1C are solved, then we will move on to the next topic of multiplication and division of rational numbers. So thanks for watching, and until the next video, take care and bye.